Okay, we can get started. So welcome to today's intelligence briefing, PIPEDREAM Malware and the Chernovite Threat Group. Again, I'm Danielle Gauthier, Senior Product Marketing Manager for Threat Intelligence at Dragos. So this is the first of two sessions. Given the global importance of this topic, we wanted to make sure we could provide the information live to as many people as possible and give you the opportunity to ask questions. So we have just a couple of housekeeping items before we get started. First, this session is being recorded and the recording will be emailed to all registrants and attendees after the webinar. Also, your microphones have been muted, but we still want you to interact with us. So please use the Q&A feature to submit any questions you have, and we're going to try to answer those as we go. Now, I'm going to pass it off to our speakers for today's session. We have Jimmy Wylie, Principal Malware Analyst, and our Vulnerability Analyst, Sam Hansen.
Hello, everybody. We've already been introduced, so we work at Dragos. We've been hammering at PIPEDREAM analysis this whole time, so we're just going to go ahead and dive in. So I'm going to walk you through the basic introductory items, a little bit of background regarding the history of Ics malware, and then we'll get into impacted hardware and devices and kind of run through the overview of PIPEDREAM's capabilities, and then talk about the appropriate mitigation steps.
Yeah, so I'm just going to dive right into kind of a high-level overview of PIPEDREAM, and then we will get into a bit more of the specifics in a bit here. So PIPEDREAM is a malware collection developed to manipulate and disrupt industrial processes. It has the ability to impact the PLCs and commonly used OT devices. PIPEDREAM has not yet been employed for disruptive or destructive effects. So this is kind of a rare case and the first of its kind of analyzing malicious capabilities before employment, which gives defenders a unique opportunity to prepare for it in advance. It's important to note that we don't know of any specific target organizations at the moment, but PIPEDREAM is a collection of utilities that the adversary could package together or use individually. This is not really a holistic attack suite with everything they need. And Dragos on the right-hand side, you can see kind of the baseball card for Chernovite, but Dragos designates the group behind PIPEDREAM as Chernovite, which follows the diamond model. It's clear that these operators are professionals. Likely they have the resources on their side to improve their capabilities and industrial impact over time. Finally, while impossible to say with certainty, we define Chernovite as the impact group, not the initial access group. So it's possible that another group would be used to gain initial access into the target environment. Then Chernovite actually, conducts the attack, causing industrial effects. So Chernovite can operate in IT and OT networks and has the potential for significant industrial impact. This is a threat that should be taken seriously. Chernovite's capacity can impact multiple key PLC types used in a variety of sectors. So we see both like specific PLC targeting, such as Schneider Electric and Omron PLCs, as well as more general OT device targeting. So again, with more time and resources, Chernovite capabilities could impact more and additional PLC vendors as development of the tools continue.
All right, so PIPEDREAM is the seventh sort of ICS specific impacting malware that we've seen since 2010. So, cue the requisite groan, but Stuxnet 2010 affected nuclear centrifuges and was very specific malware. We have Havix that was more about espionage. You move on to Black Energy, which the logistics of the attack were pretty impressive, but everything was mostly like remote interaction along with this kill disk wiper. When we move on to Crash Override, you end up with 4 DLLs that speak 4 different protocols to disrupt the transmission substation there in Ukraine. And that was just impressive because sort of the breadth of protocol knowledge used. But the actual malware analysis, like from the malware analysis, you look at the code and everything is very sloppy. It was clear that they didn't really understand the protocols in depth. But again, I mean, it worked, right? And they achieved what they needed. So you move on to Trisys, and Trisys is a little bit different in that they studied one device in depth and they understood the protocol, it's Tri-Station Protocol, and TCM, which is this wrapping protocol, it's like a wrapper protocol that wraps the tri-station, and there's very in-depth understanding, so they could download, upload programs. They could use the tool set to sort of research the device before doing anything. And so the tool sort of doubled as an attack tool and also a research utility on site. PipeDream combines sort of the breadth of knowledge of crash override with sort of the in-depth knowledge of the protocols of Trisys. It's very clear that they understand the protocols involved, they understand the PLCs. And so in that sense, you really do get a good sense of sort of adversary development over time, right? In 6 years, we've gone from something that was sloppy to effective, but something is like professionally made and easy to use. You know, there's UI concerns that they're taking into account. And that's why this is such a big deal right now.
So we're going to dive into the malware specifics, the modules, in a bit on the next slide, actually. But one of PipeDream's modules like targets various, well, all the modules combined kind of target various different devices and ICS protocols. So specifically, one of them targets Omron devices. That's controllers. There's safety controllers. There's those EtherCAT couplers. There's power supplies and servo drives. Another module targets Schneider electric PLCs and motion controllers, and kind of three of the 5 modules target various ICS protocols. So that's CodeSys, Schneider Discovery, Modbus, Omron Fins, and Opc Ua. So this essentially means that PipeDream isn't just capable of targeting the devices listed on these slides, right? It's capable of having a much wider impact and could be used to target and attack controllers from hundreds of additional vendors, especially considering how widespread some of these protocols are. As for vulnerabilities, PipeDream leverages known and undisclosed vulnerabilities to achieve its goals. So specifically, one of the modules that we'll get into in a second, it's called Lazy Cargo, utilizes CVE 2020-15368 to read and write to physical memory, which allows for the reflective loading of an unsigned driver. Other disclosed vulnerabilities in Omron and Schneider Electric are used, but we're going to follow responsible disclosure and continue our analysis before we actually talk about those more in depth.
Okay, so there are 5 main pieces to PipeDream here. So PipeDream is a term that we're just using to collectively talk about the full tool set, and we sort of assign names for every piece of malware inside of this. So Evil Scholar is the malware that's targeting the Schneider electric devices. It allows for discovery, access, manipulation, primarily through the CodeSys protocol, but it also has some stuff in there to speak Modbus that we'll talk about, as well as the discovery protocol that Schneider uses under the covers. Bad Omen is a tool that targets Omron devices. It's sort of similar capabilities to Evil Scholar, but it's a different tool because there are different protocols involved, like Omron Fins. Mousehole targets Opc Ua servers, and it can enumerate those servers. It can enumerate the nodes and attributes, as well as read and write those things. And so those are the primary PLC affecting components of this malware set. On the Windows side, there's something that we're calling Dust Tunnel. That's sort of I don't want to say standard, but it's a Windows implant, and it does all the things that regular sort of professional implants do: remote CNC, manipulating registry values, persistence, and that kind of thing. And then there's Lazy Cargo, which is a user mode executable that leverages a vulnerability to load an unsigned driver.
Okay, so here we see the attack for Ics Matrix. So PipeDream as a whole covers, I think it's 36 out of 88, which is roughly half. I think that's like 41% of the MITRE attack for ICS techniques, right? So those are the ones that are highlighted in red. And that shows a massive gain in understanding and interest towards operational impact. But I specifically want to highlight the ones on the rightmost column. So that's, that's PipeDream's coverage of loss of safety and control, view and availability. That program upload and download are certainly significant, and then manipulation of control, right? The real kind of the industrial impacts that we really want to focus on and protect. Obviously, the specific technique impact depends on the asset that's targeted. So that's the type of operations that are running, et cetera. But if executed carefully by an adversary, this could be a nightmare scenario for OT asset owners and practitioners.
Just real quick, I want to take a pause and address a couple of the questions that are relevant to what we just talked about. So there's a question here about whether or not Evil Scholar targets higher end Schneider PLCs like the M580, and whether or not Bad Omen targets Schneider Opc Ua servers. So a couple things there. We don't have any evidence yet that it targets the M580. I have to look at what protocols are involved there. If the M580 speaks code assist, it's likely that it can interact with that device. We certainly have evidence that it can talk to more devices than what's on the list that we gave you. And so it really does depend on the protocol there. Bad Omen affects Omron devices. It doesn't do the OPC stuff. Mousehole does the OPC stuff, and it can enumerate, it's a standard protocol. So if it's a Schneider device that's using OPC, it would be able to communicate with it. And then given that it can affect IT and OT systems, is it more likely that IT systems will be targeted or impacted? I mean, if the OT network is directly on the internet and they can just get into the OT network, then no. But generally speaking, there's going to be an IT intrusion through ICS kind of kill chain stage 1, and then they would pivot through to stage 2. I think in our TR of your customer, we outline like a scenario that's like that would be a little bit better for answering that question. We don't want to go too into the details because we just have too many details to cover in the actual malware set. So I don't think it's more likely. I just think that would have to happen for them to leverage these utilities. And then I think, one second, what makes Chernovite stand out as such a grand global threat? How is Chernovite known to this level of detail? I mean, we just analyzed the malware. I mean, it's just like anything else. Trisys, we know part of it is helpful because it's like a Python framework, so it's kind of easy to go through how the code works. Just like with Trisys, we could decompile the Python and take a look, and you essentially just have all the details there, and it's just a matter of reading the code. So in that sense, as a reverse engineering task, it isn't too complicated. The level of detail we're presenting here is from our initial analysis. There's still a lot more details that we're going to uncover and hopefully report on, and a lot of runtime testing and analysis, and seeing how else we can use these tools to affect devices, and maybe trying to come up with some demos and things. But yeah, it's just standard code analysis. It's just what my team does here at Dragos. What makes Chernovite stand out such a global threat? We haven't seen a tool set like this before that is so easy to use, and it can affect so many different devices. And because they're speaking sort of standard protocols here, it can just impact multiple verticals. None of the malware that we've seen up until this point sort of has that broad range of capabilities. This is like an attack suite similar to I don't want to say similar to because it's not as good as, but the design is reminiscent of something like PowerShell Empire or like Metasploit or something like that. I mean, they're going to plan on developing and adding. They're probably planning on developing and adding more modules and more plugins to this framework so they can expand their targeting to other devices. So that's why it's a big deal. It's just we literally haven't seen something like this. And detections, response, and mitigations. We'll get to that later. I'm not ignoring your question. I'm just letting you know. We'll talk about Mousehole later. Siemens PLCs, again, that depends on the protocol. We haven't specifically tested that, but if it speaks Opc Ua or has some implementation of code assist, if it speaks Modbus, it's possible it could be affected by some of those modules. And I think, is this a couple more? Is this a malware or a toolkit? I mean, it's both, right? The toolkit is a collection of malware, basically. I prefer kind of the tools like using the words like components or utilities, but I mean, they're definitely maliciously oriented. And let's see, what else? I think that's enough for now. And then we'll get to some more of these later because I don't want to pause the entire presentation. So I think the rest, some of this other stuff we're going to be talking about later on. So we'll get to that in a few minutes. All right, so back at it. So if you look at, sort of talked about in the Q&A a little bit there, if you look at PIPEDREAM's sort of design, Evil Scholar and Bad Omen, so the Schneider affecting malware and the Omron affecting malware, they're extensible and modular. So there's a plugin architecture in both that allows them to just like add new capabilities to it. And what's interesting about that, that usually indicates like long-term support. You know, they have this framework and they want to be able to add on to it more easily. So they built the foundations and they can just write smaller plugins basically for it. That also means that the malware is adaptable to new requirements. So if they need to attack a new device or they have a new target and they have some idea of what devices are there, maybe they can write some modules to just little plugins that would help them do what they need. And it's also easy to use. And me looking at that, the sort of main point there is that they're probably developing it so that operators less knowledgeable than use the tools. So here's the help docs and here's the manual, run this plugin and it brute forces the password, right? And the people using the tool don't necessarily have to know the ins and outs of the devices and the protocol. Mousehole provides a remote interactive capability for manipulating Opc Ua servers and their nodes and associated devices. So Crash Override had an OPC module, but it was like OPC DA. Mousehole is using sort of the newer standard OPC Ua, and it provides some of the same features, except it's a little bit more broad in that they can manipulate an arbitrary tag with this tool. Crash Override can only manipulate specific tags that were hard-coded inside of that malware. So in that sense, it's sort of like an upgraded Crash Override in terms of ability, at least on the OPC side. And this is also sort of the first time we've seen in the ICS space, like essentially a not great piece of malware, the Crash Override OPC module, and then essentially like another adversary kind of looking at that tool and going like, oh, we can make that better. And now we're seeing that. And so this is definitely like kind of a unique adversary development point in time. The Windows components are sort of standard, again, Windows malware, the unsigned driver thing. I mean, it makes sense. Anything after Windows 7 has driver signing enforcement and these kinds of things. So it's a pretty common tactic to leverage a vulnerable driver to load a rootkit and things like that. There was an old vulnerability way back with a virtual box driver that was kind of similar to this lazy cargo utility. But the interesting thing about the Windows components is it shows that they aren't just interested in the OT space, right? They're developing utilities so they can cover like the full stages, you know, the full kill chain, right? Inside the IT networks and pivoting into OT and then deploying their PLC tools to cause some effect or gain information or whatever. I think we can go to the next slide now. So what does the sort of design tell us about PIPEDREAM and Chernovite? Well, the breadth of knowledge required to develop these tools indicates that one, they know a ton about ICS protocols. They're well-versed in various PLCs. They almost have to have a budget for acquiring devices to test some of this stuff. And they understand how to apply this knowledge to achieve an effect. So if we look at all these indicators, we're sort of like giving like a quick assessment of like Chernovite's development arm and the group in general, right? One, they're well-versed in ICS protocols and intrusion techniques. They're likely well-funded. They're skilled in software development methods, and they're clearly highly motivated given the sort of module architecture that they have for supporting this tool set long-term. Okay, cool. So we're going to talk about some of these modules in details. I'm just going to stop really quick and check the Q&A again and see if there was anything relevant. I think a lot of this is more okay, yeah, let me cover one of these malware samples first, and then there's a lot of questions. We'll try our best to get to some of these. Okay, so Evil Scholar is the Schneider affecting component here, and it's a collection of Python along with an ELF library that speaks Schneider's discovery protocol. We don't have time to go into like every one of these plugins. If you're a Dragos customer, we have a TR that covers a lot more of this in detail. But sort of basically, there's discovery and manipulation, kind of like the main arms here, and then there's some other kind of interesting plugins. So it can conduct a DOS attack against code assist by essentially like code assist has like channels of communication. It's like sort of part of the spec, right? And devices have a maximum limit of connections that can be made, and so this thing just like opens up as many connections as it can over and over and over and over again until the device just can't talk. And then HMIs and anything else that's using code assist to manage it can't make a connection to the device to do anything. Along with that, they have another plugin that can just sever arbitrary communication channels in code assist. So you sort of look at both of those things in tandem, and you can kind of see like, well, they could sever all the connections to the device and then conduct a DOS attack, and then no one can access the device via code assist. There's a sort of packet of death attack that we're still tracking down. We're not exactly sure how that part works. At the minute, we just know it's a code assist packet. And so, time comes, disclosures, talking to the appropriate vendors and manufacturers and things, we'll try to release some information on that. And also, like, there's maintenance stuff. It can log into the device, it can log out, it can list files and those kinds of things. There's also this like proxy module that's pretty interesting that I'll sort of explain on the next slide here. So the proxy module, so that it's on just to pretend for a minute that they're just on an arbitrary host, and they send a code assist request to the target PLC that they can actually access. So in this scenario, we're sort of hypothesizing here that you have a host and your internal PLC network is sort of behind an industrial firewall, and they're on a host that can only speak to a target Schneider PLC. So they send a code assist request to that Schneider PLC, and they ask it, what is your gateway? Gets the gateway address from the PLC. It enumerates the network interfaces on the host to figure out the appropriate PLC to reach, to find the appropriate network adapter, basically, or network adapter to communicate with the PLC. And then it adds a route between the host and the gateway via the PLC. It has to have root on that host, obviously, to do that. So once it has the route in place, then it starts sending Modbus, like I think it's like read device information requests to the PLC, and then the PLC, just because of a feature of these Schneider PLCs to be able to route Modbus traffic, will send that packet to the internal network. So once it knows it can reach that, it just starts enumerating all the devices on the subnet and sending that read device request to every device there, and then getting the information and collecting it. We can go to the next slide now. So Bad Omen is a very similar tool set, except it affects Omron devices primarily by leveraging like an HTTP. There's like a CGI endpoint on the PLC, and so it just built a bunch of modules on top of this like HTTP API to do what it wants to do. Some of the more interesting things here that are I guess for lack of a better word, kind of nasty, aside from just logging in, is it can like exploit telnet connections. So it has the ability to remotely turn on telnet, and then once it does that, it uses telnet to like upload an implant onto the controller to like give it other abilities essentially. And so that shows you can upload and download arbitrary files, as well as execute binaries on the PLC. It can also sever connections, perform a denial of service attack. It can use FINS protocol to scan and identify Omron devices. It deploys TCP dump to collect network traffic. A couple other things here that are not great. It can change the operating mode of the Omron devices from program to run. It can restore backups and create backups. So we're sort of hypothesizing here that we could grab a backup from this device and then manipulate the ladder logic inside of it and then restore it. And so we do think there's a potential here for ladder logic manipulation. And then there's sort of two other plugins here that I want to talk to you about. There's the servos. It can manipulate servos via EtherCAT, and it can wipe the controller's memory. So the diagram on the left is from a Omron NJ series controller data sheet that just shows like a example configuration of how the controller would be hooked up to a servo. So I spent a lot of time talking to some of our like I'll say professional services folks about servos and things, and essentially they're like motors that move a shaft. The main thing with servos is the positioning, the position of it in sort of like an, I guess I'll say, axial space. I don't know if that's maybe the best way to put it, but for example, you can attach this motor to a pressure control valve in a pipeline to regulate the flow of gas, right? It's also sometimes used in vacuum breakers in an electrical switch yard. So the servos will shift the breaker into the energized position, and then the vacuum breaker is there as the failsafe. Also, just kind of arbitrary, but still kind of an interesting point. Like servos are used in subwoofers to make bass. So these little devices are all over the place. I was speaking to a colleague yesterday, and they use servos for the little 360-degree cameras on the bottom of drones. So these are not to say that Omron devices are all over the place, or in all those things, but that's generally what these things are used for. So the service manipulation is interesting because unlike with regular PLCs where you sort of configure an output on the PLC and it sort of relays a command or whatever to the device, the manipulation via EtherCAT is like direct, so it can control it immediately. And we haven't seen anything like this in any of the other sort of ICS malwares we've looked at. The PLC wiper is an example of how it leverages the HTTP protocol. So in this sense, they just send a query to the CGI interface, they get some confirmation, they send a fins command. And after that, they set the CPU to program mode. Then they send a command to clear the controller's memory. They reset the control CPU, and then they reset the controller, and then they set the CPU back to run mode. And I think that's it. We can go to the next slide.
Okay, so let's dive into some of the Mousehole specifics. So Mousehole is a multi-platform toolkit designed to interact with Opc Ua servers. So Mousehole has a few major capabilities. It can scan a user-specified network range for Opc Ua servers. By default, it uses TCP port 4840, but really a user can provide any port or range of IP addresses to scan for. It can brute force the Opc Ua server via a user-specified word list. It could read the server structure information, enumerate those endpoints, and read and write to specific nodes that are provided by the user. So if implemented properly, this tool could be turned into an automated destructive capability, right? So for instance, it could scan the network, find a server, brute force the login, enumerate nodes of interest, and then modify specific node values, leading to operational changes. So this is similar to the crash override OPC DA attack methodology, but a bit more impressive and involved. So the OPC Ua, of course, being the updated version of OPC DA, but this really shows how this has kind of, it shows the adversary evolution of the attack methodology. So obviously that was by another adversary group, and we're not, implying that there's a relationship between Electrum or Chernovite, but that we are seeing those adversarial skills improving over time. And there's a couple OPC Ua questions here in chat that I'd like to address. So let me scroll up. The Mousehole really, it shares a lot of functionality as OPC Ua clients, right? Like you want to read to a node. There's legitimate reasons to write to a node. There's legitimate reasons to enumerate endpoints, but it does it with malicious capability in mind. So we're going to talk a bit more in depth about mitigations in a bit, and specifically like what protections OPC Ua has built in, such as like signing and encryption and stuff, but that will be a bit later. I think there was a couple more too here. Is there any OPC DA capability, or is it all OPC Ua? It is all OPC Ua. Any else? I think we're okay to move on for now, and I can
actually hold on. Let's give it a second. This is sort of the end of the PLC affecting stuff before we move to the Windows components. I'm seeing a couple more in here. There's a question about whether or not PLCs, Schneider PLCs with physical key switches set to program, protect, and mitigate this PIPEDREAM malware. With Evil Scholar, it can upload and download files and things, but we haven't seen any. Unless I'm like completely blanking right now from the tool set, I don't recall that it can just arbitrarily set the operating mode from to program mode to burn, especially with a physical key switch. So it's likely that there's certain abilities in Evil Scholar that may actually be mitigated by setting the key switch, but we're still sort of investigating a lot of that. So I guess right now my answer is probably, but we're still testing some things to be sure of that, and I don't want to give you direct advice and not know for sure. And then there was one other. Oh yeah, I just want to clear out something like a little bit more generally, because I'm seeing a lot of questions about like vulnerabilities, and are there other vulnerabilities in these devices? And keep in mind that these tools are speaking standard protocols, and not everything about the protocols require vulnerabilities to operate. So, you know, there are some things in here where there's like default passwords that they're using. Oh, my headphone just fell out. Sorry. Yeah, so there are some things in here that leverage, like, you know, before any of these attacks, they would probably need to do some kind of credential theft, but there's also some default username and password stuff that they're doing as well. And nothing about that means that the protocol is vulnerable or that the device is vulnerable. It's just speaking code assist and doing what code assist was intended to do, or it's just responding to Finn's protocol the way it was meant to do. So this malware isn't, the focus of this toolkit shouldn't just be that there are these vulnerabilities, and if we somehow manage to patch these vulnerabilities, everything would be okay, because that's just not the case. They're not patching code assist off the system. We're gonna, at the end of the briefing, we have a bunch of mitigations that we're gonna talk through that we think will help you sort of secure your devices. And so there's a lot of questions about that too, that's coming at the end. We're gonna talk through some of those things. And I think that's it. You can go ahead and move on, Sam.
And actually one more thing too. So I'm seeing a couple questions about, like Jimmy said, vulnerabilities, and specifically related to the Opc Ua. There is no like trusted, bypass of the trusted application check. This assumes that the server does not have security. So just wanted to clarify that as well. So, all right, so let's move on to Dust Tunnel. So Dust Tunnel is a Windows implant for remote access and control. It gives Chernovite a remote and interactive command prompt to the host machine, right? So it has the ability, it has a few different like modules that it can load and unload when it wants, but it has the ability to enumerate, the host, enumerate the network, run commands from a command and control server, upload and download files, edit the registry. Again, pretty like standard implant type of stuff. So there are various anti-analysis techniques that it employs to hide, but overall, it's a pretty classic Windows implant for remote access and control. As for lazy cargo, this is a Windows executable that drops a vulnerable Asrock driver and exploits, like I mentioned prior, CVE 2020-15368 to reflectively load an unsigned driver. So this is going to be a massive oversimplification, and any reverse engineer is going to dislike what I have to say, but just for a general understanding of how lazy cargo actually works, the vulnerability overwrites a function in the Asrock driver by overwriting physical memory with code to load an unsigned, to reflectively load an unsigned driver and install that. So a write-up and the proof of concept can be found on the internet, hence likely why the adversary chose to use this technique. And this exploit requires administrator access to install the vulnerable driver as a service and interact with said driver. So previous access is required for successful exploitation. So we don't know what unsigned driver lazy cargo intends to load. It's possible that it's a rootkit designed to hide Dust Tunnel, the implant. Another possibility, depending on where it's actually installed, is that it could hide or even manipulate communication between HMIs and PLCs if placed correctly. So it's hard to say for sure, of course, but those are just kind of a few general ideas on it. So let's go through an example deployment scenario of PipeDream, and let's just kind of like walk through it. So first of all, Chernovite, or possibly a separate initial access group, obtains enterprise network access through phishing, whether that be a remote access vulnerability or previously collected credentials, etc. Chernovite would then deploy Dust Tunnel to gain persistence in the enterprise network. Once that persistence is gained, Dust Tunnel is used to enumerate the network and identify the IT and OT DMZ. Captured credentials could be used to move laterally from that spot. Chernovite then could utilize lazy cargo to deploy a network filter driver to hide or manipulate PLC to HMI communications. So that's obviously directly impacting operations. Once Chernovite has gained access to the OT network, Mousehole could be used to identify Opc Ua servers and connected control devices. Server structure and node information could be read and manipulated, again, impacting control systems directly. And then using that information gained from Mousehole, through that enumeration process, Evil Scholar and Bad Omen could be deployed to interact with Schneider Electric and Omron PLCs. Further enumeration could be achieved through, Bad Omen's proxy functionality to pivot into, protected network segments by abusing Omron's, controller routing behavior. And then finally, crown jewel objectives could be accomplished, which, highly depends. But as an example, safety controllers could be disabled and operations could be manipulated to cause unsafe conditions. So, obviously this is a made up scenario, but really trying to demonstrate that these tools do have real world impact on operations.
Okay, so obviously, like a lot of people are asking us and just thinking about, what is the impact of this and everything, just in sort of the general MITRE ICS attack, denial of control view, loss of availability control, safety and view, manipulation control, program upload and download. I mean, just the number of sheer things that it can do makes it very hard to narrow down any specific impact. Also, so we can't really say, at least at this point in time, specifically about anything, because it really does depend on the industry, the process controlled by the device, which device they're deciding to target. The impact's going to be different from a M251, depending on what it's controlling, versus like Omron's safety CPU, the 3300. So, we are concerned about the electric industry and oil and gas, but we're still doing a lot more research to sort of figure out how to give you all more specific advice about industry impacts in general. And we're hoping to sort of release more information on that in the future. But right now we don't have, honestly, like a good answer for like, yeah, if you're an oil and gas refinery or whatever. So generally speaking, it's like, do the devices speak code assist? Are you running any of these Schneider Electric PLCs? Do they speak Opc Ua? And there's sort of a good tack that we're taking right now. It really is about you all needing site owners and such doing like asset inventory and figuring out what devices they have and what protocols are on the network. And we'll talk a little bit about that in the upcoming slides. All right, so we're going to cover some of the mitigations here for various techniques and sort of try to talk about exactly like sort of why we're telling you this mitigation advice. It's to try to give you like the idea of like what capability and sort of Evil Scholar and Bad Omen and these other tools that this is going to help with. And then after that, we'll have some time to answer more questions, as there's several in here that I'm not able to keep up with and type answers to. So the first thing is changing default credentials. It seems pretty basic. But it's obvious that these actors like to leverage default credentials. So any passwords that you can change, like just change them, and that sort of mitigates some of the techniques in Bad Omen. And strict access to UDP 1740 and 43, 1105, 11740. The reason we're saying that on your Schneider devices is if you read the manuals on these things, that's basically the code assist ports for So Machine and So Machine is the older model, and or the Machine Expert. And then for non-Schneider devices, restrict access to TCP 11740, as a lot of non-Schneider PLCs communicate code assist over that port. If you can disable the net managed discovery service, because that's how they're reconning the network to even find out what devices to talk to. So if you don't need that necessarily, you can just disable it, then you should. And that's going to disable like basically a whole library in Evil Scholar. You want to monitor affected PLCs for new outbound connections, right? Think about, for example, like especially like right now, like the way what we're looking at is your Schneider HMI is a Windows device, and the library for speaking net manage is like a Linux ELF. So you're going to have this weird Linux ELF, this weird Linux box communicating to your PLC and the other way around. So you really want to monitor your PLCs for these new connections. Another example would be the proxy module, because it's obviously going to be a random host talking to this PLC that's sending Modbus traffic inside of another network that it doesn't normally communicate to. So some real network introspection needs to happen to detect these things. Let's see. And then validate the engineering workstation software. EcoStruxure, So Machine, it's possible, and we've been discussing this too, looking at the Linux binary, it's probably like standard POSIX APIs and things that it wouldn't really be a big deal to, like, if they wanted to like port that to Windows and have it work. So we're not I don't want the focus of what I just said to be like, oh, well, it's just Linux boxes. We don't have to worry about that. And HMI is obviously a target in this situation because the HMI is going to be allowed access to the target PLC. So you want to make sure that only software you know is running on that device.
All right, so let's dive into some specific Omron recommendations. So restricting access to those ports, TCP 80, TCP 9600, and UDP 9600 for all Omron PLCs, right? Those standard ports that are used, and really only allowing EWS systems to communicate on these ports, right? That absolutely require communication to the PLC. Similar to what we had on the last slide, validate the software installed on the engineering workstation, such as Omron Sysmac, the CX1, and the NXIO configurator, removing unnecessary software and applying application allow listing software as well. And just restricting the workstation from making outbound network connections is always a good idea. As for Opc Ua, enabling security by ensuring Opc Ua is configured with a security profile and keys and passwords are stored securely. So this is usually done in the PLC programming software, but if possible, reconfiguring those devices to use the signing security profile, which allows packets to be inspected by network security appliances and ensures that Opc Ua machines only respond to messages from authorized senders. Disabling the Opc Ua discovery feature, that always helps reduce the attack surface, and ensuring guidance in the table is followed really can help mitigate that risk of mouse hole. And please see opcfoundation.org/security for more detailed information on how you can secure those systems. So kind of a big thank you to OPC Foundation for their willingness to meet with us and helping clarify some of the questions we had regarding security profiles and general best practices. It was great to meet with them. So.
Okay, so talk about some other general things that'll just be helpful. And so we can't just be focused on ingress and egress for this stuff anymore. You really need to be able to look at all those like squishy internal bits inside of your network and PLC to PLC communications and such. So you really need to start doing that kind of, if you aren't already, start doing that kind of network introspection to find those strange connections in between the PLCs. And of course, you want to do network telemetry analysis, look for non-standard workstations, accounts, identify unusual interactions. You should, if you can, isolate your safety systems. I think that's a lesson learned from Trisys, right? But they can target a safety CPU in this and sort of the same sort of mitigation strategy. If you can isolate that device and then verify any configuration changes, comply with change management procedures, right? Make sure that updates happen in the appropriate time window and you aren't getting a random code update at 1 o'clock in the morning on a Saturday or something, which, I assume would be non-standard in most organizations. And if you can, isolate mission critical SCID systems. So in these situations, those systems don't necessarily need Ethernet and you can just like hardwire the IO. So you don't even have to worry about any of these things even being able to talk to the SCID system. Next slide there. Right, and then there's just some long-term readiness stuff that you should we were recommending y'all should be implementing. One is an ICS focused incident response plan. So you want to create and update a plan accompanying SOPs and EOPs for operating with hampered or degraded control systems, and then have a spare parts and inventory plan for any of the critical systems in your network. That includes hardware, software, your firmware, configuration backups, licensing information, plans for sourcing so you can get things in an emergency, maybe even the implementation of cold backups so you can rapidly replace devices on the ICS level. And of course, you also want to rehearse these plans and make sure they actually work and you understand who the points of contact are and what happens when Bob is on vacation, and those kinds of things. Okay, and I think that's it. I think we're moving on to Q&A. So thank you if you've stuck it out so far. We've got about 15 more minutes. If you can give us a second to start reading through some of these questions and see which ones we can address. I do want to stress, because I'm seeing a lot of questions. I stress something really quick because I'm seeing a lot of questions in here. that, you know, the stuff that we're telling you right now is sort of the result of like initial analysis. So we don't have every answer to all your questions, all right? And so we're not trying to be evasive and sound like, you know, couch it the wrong way, but sometimes like I legit just don't know the answer yet because we're still looking at it. And so just letting you know that, you know, we're trying to get that information out, and we will, you know, sort of further in the future and such. But you know, we just found this stuff. I don't know if any of y'all were around during Trisys, but something similar happened with us in Trisys, where it's like, okay, we got this part covered. We don't know what this piece does, but let's talk about this first, the Python stuff, and then move on to the next bit. And that's kind of where we're at right now.
So I see a question. So someone asked, does the Asrock driver imply that this is a targeted attack tool? No, this could be used really against any Windows system. It's not just Asrock PCs or motherboards. This could just be a general Windows system, and lazy cargo would still be effective.
Who does Dragos assign attribution? We're calling the group Chernovite. We don't, Dragos doesn't do attribution beyond that. We just label the collection of activity or behavior, assign it a name, and we collect any associated behaviors that we think are the same group, and then we leave it at that. We let other groups and large governments worry about who is actually behind these groups. So that takes care of that at least. Let's see. We already covered mitigations, so I'm just going to go ahead and, okay, so right, so I'm looking at this question from Downing. Can we assume that the threat group is using common vulns found in Codesys version 3? You mentioned that it's using the threat group, that the threat group used a DOS attack. Would that be max channels, buffer size? Yeah. It's very similar to that, like just taking advantage of the max channel stuff. We're still working on like collecting all of the CVs involved with the Codesys and everything. So I guess like from a reverse engineering standpoint and analysis standpoint, if you think about some of the other stuff, like the other ICS attacks and kind of malware in general, normally like Trisys is basically one piece of malware, right? It's the Python with some embedded PowerPC. With PIPEDREAM, it's like we found, we got five large pieces of malware that we're working through, all with their own plugins and things. And so it's a lot of things happening at once, and for us to go through. So we don't necessarily have the specifics yet on a lot of this stuff, because we just have to look at it more deeply. There's some other questions. Another one. One more thing. I've seen a few questions in the chat, and I was like literally joking about like ransomware stuff the other day, because I was like, wow, I felt like up until like, PIPEDREAM, the PIPEDREAM releases and things, it's like the whole world was just worried about ransomware, and now I'm seeing these questions and I'm like, has it been used for ransom attacks? I mean, it could. I don't think that that's what this tool set is for. I don't think they'd want to burn something so usable for something as silly as ransomware. This feels a little bit more, I'm going to say, not that the ransomware groups aren't professional, but I don't like complimenting them. So I'm going to say that this tool set seems a little bit more professional than something a ransomware crimeware people will put together. They're more concerned with just obfuscation and some other stuff that as part of their kind of regular basis. I guess what I'm trying to say is they operate at a different mode, and I don't see why this tool set would operate. Why they would. Okay, let me backtrack. Easier this way. If you want to ransom an OT network, you don't need all this stuff. There's so many Windows systems on the network that you could just deploy and encrypt. Like, you don't need to develop specialized tooling to get that effect in, unless you were just like really trying to be mean and you also wanted to wipe PLCs. But it's not necessary to get your money necessarily to do that. So it just feels like this is a really complicated way to go about it if you're trying to ransom OT network. So I'm not saying it's something that couldn't happen. I just don't see that as a likely outcome from Chernovite's tool set.
I see a question related to using certificates for authentication. I assume that this is in regards to the Opc Ua and mouse hole. So yeah, if the server is configured properly, If these certificates are stored properly and securely, then yeah, mouse holes should be mitigated. Of course, it can be more complicated than that when vendor software is involved, and you might not have an engineer or operator, click all the right boxes and go through all the right settings in order to set it up correctly and properly. And that's where we really would push reviewing OPC Foundation's best practices for security. But yeah, if everything is done correctly and certificates are stored properly, then that should be mitigated.
There's a question here about lazy cargo. Do you think this group actually developed lazy cargo, or if they borrowed it? Sorry, I lost the question in the Q&A, but I don't. Maybe that wasn't in the slide, but the CVE proof of concept for that vulnerability is online, and so they basically just weaponized it. So they have a large portion of the source code for that tool is basically the same as the POC source code is very similar to the code that we're seeing in lazy cargo, and so they just took that and they weaponized it to add their own driver for their own purposes. I think, let me see if I can find some other ones here. It keeps dropping me back to the bottom for some reason. I'm not sure why. Okay, more ransomware. I'm gonna skip over those. I think that's enough. Someone's asking about the name. Does the name come from previous blackouts and lessons learned to build PIPEDREAM? I mean, naming malware in activity groups is fairly arbitrary. Like whatever analyst decides they want to name it, and then we just kind of get together and say, like, that sounds cool. There's not really we just need something to refer to these groups to. And so Chernovite is just the one we decided on. It's not really based on any history or anything like that.
I see a question with regards to research being conducted to target spear phishing or to gain initial access. Absolutely. Yeah, they could absolutely conduct OSINT and make their phish or their initial access vector significantly more effective. That is, we would absolutely expect to see that.
There's a lot of questions here about, like, where'd you find it? How'd you find it? Like, I don't know if any of y'all saw Rob's S4 talk, and it's going to be posted online, but no one, Dragos didn't discover this. No one discovered this. A sort of undisclosed partner relationship, I guess an undisclosed partner is the appropriate way to say that, passed this off to us. So, and we're not going to talk about how they found it or how we think they might have found it or anything like that, or we are not aware of any particular what am I saying? Like I said, we're not aware of any specific target organizations right now, but we can't go into any more details than that, and that's the honest answer. Okay, all right, so we got about 5 more minutes here. We're seeing what is still being investigated, like all of the malware. So, we're looking at things right now and looking at these protocols, and we realize that there's potential for all these other things. So, there's 4, 5, 6 of us now, putting new devices on the range, running the samples, seeing how it's going to operate. Does this module actually work, right? Is the brute force successful here? Is the brute force successful there? What happens if you change some configuration on the controller? Does it still work? There's all kinds of things we're trying to run through to see exactly. Like if you think about it, it's sort of like doing. It's very akin to sort of doing what would you call it? Quality engineering on like regular software development, right? And like, oh, let's run it and test it here and there and the other, and just a lot of dynamic analysis types of things on it. So we're still investigating all of it, really, except for maybe lazy cargo. Lazy cargo we're basically done with. We're mainly investigating the 3 sort of PLC affecting components at this time in terms of the malware analysis. I think the hunters and everyone else are doing some other things that, at least right now, I'm not 100% aware of it right now because I'm too busy doing the actual malware stuff. So Yeah, there's just a lot that we're still investigating. There's no impact devices using IEC 104 protocol. You may be getting that mixed up with the InDestroyer 2 stuff that came out like right before, essentially, I think what we released just before S4, and I think right before that, the InDestroyer 2 stuff came out. I think we've released an advisory on it, or we were going to. I think we did, at least to our customers. As far as I can tell, so yeah, that's a different group. I'm going to say probably Electrum again. As far as so far, just speaking to the analyst that was looking at it, it doesn't really look like it's that different from the IEC 104 module that happened during crash override, but that's not any of PipeDream's things. That's a completely different attack. Okay. I do want to point out too, like, especially for customers, that y'all are allowed to contact us and ask us more questions. So if we don't get to something, I'm kind of like randomly dipping and pulling questions out here. So if we don't get to something you need an answer to, you're more than willing to, send us an email and we'll answer what we can. We're trying our best to get the right information out to our customers and general public. Believing that's why we're doing this.
And I saw a question wondering about how we contract. And so that would be intel@dragos.com. Will get us there. So feel free to email.
The tool like this have an integration to search and target victims automatically. Yeah, honestly, I don't know enough about Shodan integration to answer that. I mean, they could probably use Shodan for targeting, from what I understand about how that works, but I don't know if they would integrate with it, and I don't see any indication that they're planning that kind of thing. We sort of, when you're doing this analysis, you sort of look at the code as is, and you can make some assessments as to like where they might be developing, sort of like based on current implementations, but like just integrating, we're not seeing any modules specifically that are trying to integrate with third parties, but just generally speaking, you kind of can only do, like, in terms of an analytical leap, maybe like one step into the future, maybe two, right? For example, like I'm looking at this and, I wouldn't say something like, oh, they'll probably add a 16850 module. I don't know. I don't know what their operational requirements are, and whoever their bosses are telling them to target, or, what facilities they're actually looking at right now. So it's pretty open-ended, but no, I don't see any indication of third-party integration at all. There's asking about how they would keep it hidden modules. So right now we're not seeing any like obfuscation. I mean, they could easily repackage Python, compile it and obfuscate it and do some standard packing, encryption, that kind of thing, to evade AV vendors and just generally avoid detection, right? There's some, I don't know if any of y'all looked into the Conti dumps, but they were talking about how they like retest the Conti samples like every 4 hours when there's like a Windows Defender update. So they could certainly just use sort of standard malware techniques for obfuscation. The lazy cargo is a little concerning because of that. We don't know what driver it's trying to load. We just have the loader. So, it's pretty reasonable to think that they would deploy a rootkit to sort of like hide the dust tunnel implant, or maybe even hide their devices, or do something nastier like install a network filter so that HMIs or certain programs on the device don't even see the communication. So there's that sort of thing that maybe could happen in terms of protection and evasion. But we don't know exactly what that is. I think, at least right now, the best thing that we're recommending, I think, is the network telemetry, and really paying attention to that, because they have to talk to the PLCs, so that's going to be there, and the protocols are standard. So I think that's it might be better to focus on that aspect of things for now, until we can maybe discuss some better host-based things. Someone else also asked whether or not it works on Windows XP. I think it's a hard question to ask, because we haven't tested on Windows XP. I know that Dust Tunnel and Lazy Cargo will run likely on Windows 7 and up, just because of the way it's oriented. I'd have to like look at all the APIs involved to see if those are actually in Windows XP. So some of them are and some of them aren't, and I'm not 100% sure about XP compatibility. I think the implant would be, but I don't think that lazy cargo would work. I don't think the driver would necessarily load the vulnerable. I don't think the vulnerable driver can load on an XP machine, but I'd have to double check that. And that's something we'll follow. We'll chase down. Thought there was one more question about that, but oh yeah, just to reiterate, I think lazy cargo will load a driver on Windows 7 and up. And someone else was asking a question about whether or not lazy cargo only works on certain motherboards or something like that. The driver is and we'll close that in a second. I want to keep you. I just realized what time it was. The driver isn't. It's part of like a motherboard utility. It's really silly. It's for like configuring the colors of LED lights on the motherboard, right? And when it loads, it doesn't check what motherboard it's on. So you can load the driver and use the functions for reading physical memory without it causing a problem. So it works on basically any, I think what, 64-bit Windows system. It will allow this exploit. So that's I think all we have time for today. Like I said, if customers, you can definitely send us questions, and also like we're on Twitter. Like if you DM me and it's not anything crazy, like I'll try my best to help you out if you're an operator, right? We're this isn't just our job. We care about this a lot, right? So we thank all of you for joining us, and I hope this information helps your organization sort of like develop a defensive posture for some of these tools. And as we figure out more things, we'll try our best to update the public on what those new things are. If we can come up with new mitigations for you and everything else. So now stay safe and take care. Thanks, y'all.
Thank you.